Permutations and combinations. What we're going to be looking at in this video is a couple of aspects of probability. To start with, we're going to talk about the fundamental counting principle, which says that if event capital M can occur lowercase m ways, and event capital N can occur lowercase n ways, then event capital M followed by event capital N has lowercase m times lowercase n ways. All right, there's a lot going on in there, but overall it's a really simple concept here. Let's take a look at example 1. A deli offers a lunch special if you choose one from each of the following types of sandwiches, side items, and drink choices. How many different lunch specials are possible? Okay, so let's start small. Suppose that you are going to choose a ham and turkey sandwich. If you choose the ham and turkey sandwich, you have 4 side items that you can follow it by, which means if we're just looking at the sandwich and the 4 side items with it, you have 4 different combinations that you can create. Okay, now suppose that you are going to choose between the ham and turkey sandwich or the salami sandwich. If you do that, you have 4 choices that follow the ham and turkey sandwich and 4 choices that follow the salami sandwich, which means you have a total of 8 combinations. And if you add in the tuna sandwich, you're going to have 12 possibilities. And if you add in the club sandwich, you're going to have 16, and then you're going to have 20, and then you're going to have 24. In other words, if you're just looking at these 2 categories, you have a total of 6 times 4 possibilities, which of course would be 24. Okay, so if we think that we have 24 different combinations that we can create with sandwiches and side items, then each of those combinations can be followed up with a different choice of a drink, which we have 5 choices of. So overall, we're going to have 24 times 5 choices. In other words, we've got 3 possible events. Above, it's described with just 2 events with capital M and capital N, but we really have 3 different events that are happening. Each event has a certain amount of outcomes. This has 6, this has 4, this has 5. And if we take the product of all of those outcomes, we get the total amount of combinations. So here we have 24 times 5, which is going to be 120. And you can do the math out of order if you want. You could look at this as 4 times 5, which is 20, and then 20 times 6 also gives you 120. So surprisingly, given these limited options, you can actually create 120 different combinations. And that would be called the fundamental counting principle. Next, what we're going to do is look at the difference between combinations and permutations. The 2 of these are somewhat alike. The equations that we're going to look at look fairly similar, but there is a difference between the 2 of them. A combination is a selection of items in which the order does not matter. The number of combinations of n items chosen r at a time can be calculated using this expression. The subscript of an n is going to identify the number of items that are available, and then the subscript of r is going to identify the number of items that we're going to choose. In the expression, you're going to notice that you have an exclamation point that is actually referred to as a factorial in mathematics. What it represents in mathematics is the product of all the numbers starting with n and all the positive integers that precede that one. Okay, so for example, if n is 3, if n is 3 here, it's going to be the product of 3, 2, and 1. If n is 10, it's going to be the product of 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. On the bottom, you're also going to have an r factorial and an n minus r factorial. Example 2, suppose that your school requires you to choose 4 books to read on summer vacation from a reading list of 12 books. Okay, our n value here is going to be 12. You have 12 possible items to choose from, and what you need to do is choose 4 of those, so that'll be the r value that you're going to choose. And in this case, the order in which you choose those books does not matter here. It doesn't make any sense in the context, which means that this is going to be a combination. A permutation is going to be a lot like a combination, except that the order in which you choose those items would make a difference. Here, it doesn't. You just have to choose 4 books out of 12. So the question, of course, here is how many different ways to choose the books are possible? Okay, we're looking for a combination of choosing 4 books out of 12. Okay, so we can write this as a combination 12, choose 4. Okay, we read this as a combination of n choose r. We're doing a combination of 12 choose 4. And our calculation looks like this. we take 12 factorial, divide that by 4 factorial, times n minus r factorial, which will be 12 minus 4 factorial. Okay, and then to simplify things a little bit here, we're going to get 12 factorial over 4 factorial times 8 factorial. All right, though you can type this into a calculator and get the answer, and that may be preferred, I think it's important to actually see how the calculation works. Okay, so 12 factorial literally means we got 12 times 11 times 10 times 9 times 8 and so on, all the way down to 1. Of course, when you multiply by 1, it doesn't really make a difference. We can go ahead and include it, but it doesn't change anything in the product. Okay, that is going to be divided by 4 factorial. Whoops. We're actually expanding this out. 4 times 3 times 2 times 1. Again, the 1 doesn't really matter. And 8 factorial. Okay, and one thing that you're going to notice here is that the top and the bottom do have a lot of factors in common. In fact, all of this right here, all of that is the same thing as what we've got here. So all those terms can be canceled out. And of course, you don't really need the 1 there. And it simplifies down to this. We have 12 times 11 times 10 times 9 divided by 4 times 3 times 2. All right, so then I could also just take that to the calculator if I want, but you may notice that some things can cancel as well, just as a coincidence in this problem. The 12 can cancel with the 4 and the 3. Don't really need those. You can even cancel out the 2 if you change the 10 to a 5. So ultimately, we're looking at 11 times 5 times 9. All right, so this would be the same thing as 11 times 45. And if you know a certain trick to multiply by 11, what you can do is take the 45, you write down the last digit, then you add the 2 digits, which will give you 9, and write down the first one. Oh, I can just box that. And that will be our answer, 495. However, you can type the whole thing into the calculator from the beginning. Okay, so I'm going to set up a fraction. The top is going to be 12 factorial, so I'm going to type in 12. Factorial, you'll find that under the math button. Okay, the math button's here. You go to the math button, move over to probability. It's choice 4. Okay, and then for the bottom, we've got 4 factorial times 8 factorial, which you can just type side by side. And there you go, 495. All right, next. A permutation is an arrangement of items in which the order of the items matters. So this is different than a combination. The order in which we choose the items is going to make a difference. The number of permutations of n items of a set arranged r items at a time is going to be given by this expression. Okay, it's important that we acknowledge it says it's a set arranged r items at a time. So it isn't that we're just choosing r items, but we're choosing those items in a particular order, which means that you're going to have a greater number than you would from the combinations. Because in a combination, we didn't really care what was first, what was second, what was third, what was fourth. Here, when you choose something first versus choosing it last, it does make a difference. So you're going to get a higher number from this. Okay, in the expression, you can actually see that. You're going to notice that the expression for a permutation looks a lot like the one for a combination, except it doesn't have an r factorial. So what that means mathematically here is that the top is not going to be divided by that extra factor, whatever r factorial would turn out to be. And overall, if you're not dividing by that extra number, then you're going to get a greater value than you saw in the combinations. So capital P is going to represent a permutation, which is going to instruct you to use this expression. We're still choosing from a group of n, and we're choosing r items, but those R items need to be in a particular order. Okay, so this is N choose R still, but as a permutation. All right, example 3 is one of these cases. The environmental club is selecting a president, a vice president, and a treasurer. Okay, so you have a group of people, and you're choosing 3 positions, a president, a vice president, and a treasurer. But who gets whichever title does make a difference. Okay, so how many different ways can the officers be chosen from 10 members? Okay, so we have these 10 members here, and any 10 of them can be the president, and any 10 of them can be the vice president, any 10 of them can be the treasurer. Okay, so it's not just about selecting 3 people from the group, but it's about selecting them so they fit a certain role, and that would be a permutation. Okay, so we have 10 items. We're going to choose 3, but as a permutation, and that is going to be equal to n factorial, in this case, of course, n factorial is 10 factorial divided by n minus r factorial, which is going to be 10 minus 3 factorial. Okay, so that's the same thing as 10 factorial divided by 7 factorial. And if you recall from the last example, 7 factorial is just the latter end of 10 factorial. So if we think about the top, it's going to be 10 times 9 times 8, and then everything after that is exactly what we have on the bottom. So you can go ahead and eliminate all of that. This is the same thing as 10 times 9 times 8. 9 times 8 is 72, times 10 will be 720.
Wait, what?